Hello friends, today we are going to discuss what are string ciphers and block ciphers. Let us first recall a very basic term, symmetric key ciphers. In symmetric key ciphers, a single key will be used for both encryption and decryption, and both algorithms will be inverse of each other. Stream and block ciphers. Symmetric ciphers are divided into two categories, stream ciphers and block ciphers. This categorization is applied to both modern ciphers and traditional ciphers. The only point about modern ciphers and traditional ciphers that we should keep in mind is that traditional ciphers focus on the encryption of characters, whereas modern ciphers focus on the encryption of bits. Stream ciphers. In stream ciphers, encryption and decryption are done typically on one symbol, such as a character or a bit. That is, we use one plain text character to generate one ciphertext character. Character to character are encrypted into ciphertext characters. Stream ciphers are called stream ciphers because we have three streams: a plain text stream, a ciphertext stream, and a key stream. Suppose that the plain text stream, ciphertext stream, and key stream are P, C, and K respectively. From plain text stream, if we choose first character, which is P1, and from key stream we choose first character, which is K1, and they both are fed as an input to the encrypting algorithm, we will get C1, that is first character of ciphertext. Similarly, with inputs K2 and P2, we will get C2 as an output, and with inputs P3 and K3, we will get C3 as an output. Characters in plain text are fed into encryption algorithm one at a time. On similar lines, ciphertext characters are also generated one at a time because there is a one-to-one mapping, one-to-one relationship between plain text characters and ciphertext characters. Coming to key stream can be created in many ways. It can be a stream of predetermined values. So obviously both the values will be known to both sender and receiver. It may be created one at a time using an algorithm which will also be common among sender and receiver. The value may depend on plain text and ciphertext characters or previous key values. This figure explains the working of stream ciphers. This figure shows the moment where the third character of plain text stream is being encrypted using the third value in the key stream. We have plain text plain, key stream K1, K2 up to K5, encryption algorithm E. Then the third character A is fed into the algorithm with K3, output is D, which is third ciphertext character. Some examples of stream ciphers: active cipher, monoalphabetic cipher, beginner cipher. Block ciphers. In block ciphers, a block of plain text symbols of size M, where M should be greater than 1, are encrypted together, creating a group of ciphertext of the same size. Now, note the difference. In stream ciphers, we are using one character of plain text to generate one character of ciphertext. In block ciphers, we are using one block of plain text to generate one block of ciphertext. A single key is used to encrypt the whole block, even if the key is made up of multiple values. A ciphertext block depends on the whole plain text block because we are generating block by block. There will be a one-to-one mapping or relationship between a plain text block and a ciphertext block. Given figure shows the concept of a block cipher. We have a plain text, key K, encryption algorithm E. First, the plain text is divided into blocks. Here M is equals to 3, so whole text is divided into blocks of size 3. When the second block is fed as an input to the algorithm with key K, the output will be corresponding ciphertext block. In input block we have characters I and T. In output we have characters D, P and V. So for first block PLA we have output SOD. For second block I and T we have output block DPV. Playfair cipher and Hill cipher are some examples of block cipher. In block ciphers, we cannot say which plain text character is used to encrypt this particular ciphertext character, but we can always say that this plain text block is used to encrypt this ciphertext block. So each character in ciphertext block depends on all characters in the plain text block. That's why a block cipher is a polyalphabetic cipher. In practice, we generally use a combination of both block ciphers and stream ciphers. Blocks of plain text are encrypted individually, but they use a stream of keys to encrypt the whole message block by block. Each block then uses a different key that may be generated before or during the encryption process. Result will be a more potential, more efficient cipher which uses the qualities of both block cipher and stream ciphers.